A 562 Newton truck slides down a frictionless incline plane. Angle is 30 degrees. So if we've got a plane and we've got 30 degrees and we've got the truck, and it's not its mass, it's its weight, that is 562 newtons. Once I know that, I have got a component that is perpendicular to the plane, and that is the adjacent side, so it's going to be 562 times by cos 30, and that will be equal to the normal. And we've then also got the opposite side, so that's going to be 562 sine 30 degrees. 562 sine 30 turns out to be 281 newtons, and the cos 30 turns out to be 486,71 newtons. Now, the green line, the parallel to the plane, is actually that force over there, and that is the force that is causing it to accelerate down the slope. So I am going to say force resultant is equal to the big force, which is the force down the slope, minus a small force. This is a frictionless plane, so there's no friction. And then it is the mass. We need to work out the mass of this particular object. So if we just work that out, we need to take 562 and divide it by 9,8, and we land up with a mass of 57,35 kilograms. And so it is 57,35 A equals 281, and the acceleration turns out to be 4,9 meters per second squared down the slope. The next example asks you to take a look at what if there was some friction on this plane, and the frictional coefficient that they gave us is 0,3. So now there is an upward force on this plane, and that upward force is going to be equal to frictional force is equal to the coefficient of friction times by the normal force. I've got the normal force, it's 486,71. And so my frictional force turns out to be equal to 146,01. That's the force up the plane. Down the plane, I've still got this 281. So what is the force resultant on this particular object? So force resultant is equal to big force going down the plane, 281, minus small force, 146, that's the frictional force, and that's going to be 134,98. But that is also equal to mass times acceleration. So it's 57,35 is equal, mass times acceleration. So acceleration, 134,98, divide through, and your acceleration turns out to be 2,35 meters per second squared. So that's the first. The next one, we've got a weight of a vehicle of 12,000 newtons, and it's parked on a 36-degree slope. And we've got 12,000 newtons. In fact, sorry, I'm going to do it as the weight over here. 12,000 newtons. And when I work out the mass of that particular vehicle, I've got to divide by 9,8, so it's 1224,49 kilograms. And that's just 12,000 divided by 9,8. Now I can work out the component perpendicular to the plane. Remember, this is 36 degrees, and I know that this is the adjacent side, so it's going to be 12,000 cos of 36 degrees, and that turns out to be equal to, I don't know if I'm even going to need it, so let's not worry too much. Over here, I've got the opposite side, 12,000 sine of 36 degrees, and that turns out to be 7,053,4 2 newtons. So the brakes fail and it starts to slide down the slope. We've got the force with which it's going to slide down the slope. There's no friction, so I don't have to worry about friction. What is the acceleration of that car? Force resultant is equal to mass times acceleration, and it's big force minus little force. And in this case, there is only one big force, and that is the component of weight. So the component of weight that is parallel to the plane, and I land up with 1224,49 times acceleration is equal to 7,053,42. And my acceleration turns out to be 5,76 meters per second squared down the slope. The next part of the question says how fast is it moving after 30 meters? So I can use an equation of motion, and my equation of motion is going to be v squared equals u squared plus 2as. I know that it started at rest. I've worked out the acceleration is 5,76. It has traveled 30 meters, and when I square root that, I get 18,59 meters per second as the speed after it has moved for 30 meters. An inclined plane has an angle of 40 degrees. I've been given a coefficient of friction of 0,15. Starting from rest, how long will it take a 4 kilogram block to reach a speed of 12 meters per second? First, I'm going to need to work out the acceleration. So if I'm going to draw this plane, it's 40 degrees. I've got this object over here. It's 4 kilograms. When I work out the weight of that, it's therefore 39,2 newtons. And the reason for that is it is 4 times 9,8. I now say component perpendicular to the plane is going to be 39,2 cos of 40 degrees, because it's the adjacent side to that 40. And then I can also work out this side over here, which is going to be 39,2 sine of 40 degrees, because it is opposite the 40 degrees. And that turns out to be 25,2. And this turns out to be 30,03. That is equal to the normal, 30,03. I've got the force down the plane that I've worked out. And now I've also got a frictional force. Now my frictional force, remember, is equal to the coefficient of friction multiplied by the normal force. Luckily, I've got the normal force, so I substitute it in. And I land up with 4,5 newtons. Now I take the big force minus the little force. So on this plane, I've got 25,2 minus 4,5. And those down the plane, up the plane, subtract them from one another. And that is going to be equal to the mass times acceleration. My acceleration is therefore going to turn out to be 5,17 meters per second squared. And that's not all. They want me to know how long it's going to take. So I need to say v is equal to u plus at. I have been given a final speed of 12. It started from rest. The acceleration I've calculated. How long is it going to take? Rearrange, and I get 2,32 seconds. We've got a 20 kilogram block. It's sitting on an incline. And we've got a coefficient of friction of 0,3. So it's 30 degrees over here. The box is 20 kilograms. If it's 20 kilograms, I've got a weight. The weight is going to be 20 times 9,8, which turns out to be 196 newtons. Working out my 30 degrees is over there. This is the adjacent side, so it's 196 cos of 30 degrees. And that turns out to be 169,74 newtons, and that is also your normal force, of course. And then if I go over here, I land up with 196 sine of 30 degrees. That turns out to be 98 degrees, and that is the component of weight, sorry, not 98 degrees, 98 newtons, acting down the slope. I'm being given a frictional coefficient, so I need to work that out. Friction is equal to the coefficient of friction times the normal, 0,3 multiplied by 169,74, and I land up with 50,92 newtons. So what is my force resultant? I am going to say force resultant is equal to the big force down the slope. Remember, I'm interested in the movement in that direction, minus the frictional force, and it's 20A is equal to 47,08. Divide through by 20, and my acceleration turns out to be 2,35 meters per second squared down the slope. An incline makes an angle of 30 degrees with the horizontal. What force is required to cause a 15 kilogram box to slide up the plane with an acceleration? So I've been told force resultant is equal to the mass times the acceleration, and that is going to be 80 newtons. That is also going to be equal to the big force, so I need to apply a force minus the weight parallel to the plane. So I'm going to be looking at two forces in that direction. One I'm going to apply, and the other one is going to be the component of weight that is down the slope. So that's weight parallel to the slope. I can work out the weight of this block, and it is going to turn out to be 147 newtons. This 30 degrees is going to carry into there, and I'm going to have a perpendicular component to the weight, or the component perpendicular to the plane is 147 cos of 30 degrees. And then we are going to go 147, it's the opposite side, sine of 30 degrees. And when I work those out, I land up with, we'll double check in a sec. At the moment, I'm only interested in the component parallel. That turns out to be 73,5 newtons. We'll worry if we're going to, we don't have friction, so we're not too worried about what's going to happen with the normal. We don't need to work that out right now. So, I know that 18 is equal to some or other applied force minus 73,5 newtons. So therefore, my applied force is going to be 91,5 newtons up the plane. Remember, this has to move up. What happens if it's going to go down the plane at that particular acceleration? Well, now I've got a slightly different situation. I am going to say that force resultant is equal to big force that's going down the plane minus some or other applied force. My force resultant down the plane is, in this case, again, I want it to go at exactly the same speed, and it's the exact same mass. So it's 18. It's just in the opposite direction. My weight hasn't changed, 73,5, minus some or other applied force up that plane. And this time, I'm going to get that the applied force has to be equal to 55,5 newtons. Again, I need to, in essence, this block would go sliding down the plane with that force over there. In order to have a resultant that is so low in comparison, 18 is much smaller than 73, I am going to have to slow it down and apply a force up the plane.